An electrical tap is a connection point on a transformer or power line that allows for a portion of the voltage or current to be diverted for use by a specific circuit or device. When a circuit or device is tapped, it is directly connected to a tap on a transformer or power line. This allows it to receive a specific voltage or current level. A mast is a tall, vertical structure that supports electrical equipment, such as power lines or antennas. A branch circuit is the wiring that runs from the electrical panel to individual devices or circuits. It typically consists of a circuit breaker or fuse, wires, and a switch. Let's break down the components of a branch circuit. Firstly, the electrical panel distributes electricity to different circuits in the building. Secondly, the circuit breaker or fuse protects the circuit from overload or short circuits. Thirdly, the wires conduct electricity to the device. Fourthly, the switch controls the flow of electricity to the device. For visual examples, you can find images online of electrical panels, circuit breakers, branch circuit wiring, and masts. Some resources for learning about electricity are Mike Holt's Illustrated Guide to Electrical Exam Preparation, which is a comprehensive guide to electrical theory and code, the National Fire Protection Association 70, the National Electrical Code, which is the governing document for electrical safety, and Electrical Construction and Maintenance magazine, which provides industry-related articles and resources. Consider enrolling in online courses offered by reputable organizations like the International Association of Electrical Inspectors. The electrical panel serves as the central distribution point for electricity within a building. It receives power from the utility company and divides it into separate circuits, each protected by a circuit breaker or fuse. Circuit breakers and fuses are essential safety devices that prevent overloads and short circuits. They are designed to interrupt the flow of electricity when the current exceeds a safe level, protecting wiring and equipment from damage and preventing electrical fires. Wires are the conductors that carry electricity from the electrical panel to the various devices and outlets throughout the building. They are typically made of copper or aluminum, which are excellent conductors of electricity. The size and type of wire used in a branch circuit depends on the amount of current it is expected to carry. Switches are used to control the flow of electricity to individual devices or circuits. They can be simple on/off switches or more complex devices such as dimmers or timers. A tap on a transformer allows you to obtain a different voltage level than the primary voltage of the transformer. For example, a transformer might have a primary voltage of 480 volts and taps at 240 volts and 120 volts. This allows you to supply different voltage requirements of various loads in a building from a single transformer. A mast is typically used to support overhead power lines entering a building from the utility grid. It provides a secure and stable point of attachment for the service entrance conductors. Branch circuits are designed to supply power to specific areas or devices within a building. They are typically classified by the amount of current they can safely carry, such as 15 amp, 20 amp, or 30 amp circuits. Each branch circuit should be protected by a circuit breaker or fuse of the appropriate size. Understanding the relationship between voltage, current, and resistance is fundamental to understanding electricity. Ohm's law describes this relationship mathematically, stating that voltage equals current times resistance, or volts equals amps times ohms. This law can be used to calculate the current flowing through a circuit, the voltage drop across a resistor, or the resistance of a component. In electrical systems, grounding is a critical safety measure that provides a low impedance path for fault currents to flow back to the source. This helps to protect people from electric shock and prevent damage to equipment. Grounding systems typically consist of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel and other metal parts of the electrical system. Bonding is another important safety measure that involves connecting all metal parts of the electrical system together to create a common electrical potential. This helps to prevent voltage differences between metal parts, which can create a shock hazard. Bonding is typically accomplished by using bonding jumpers to connect metal conduits, enclosures, and equipment together. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years and provides detailed requirements for everything from the size and type of wire to use in a circuit to the proper methods for grounding and bonding. Adherence to the NEC is essential for ensuring the safety of electrical systems. When working with electricity, it is important to always follow safe work practices. This includes wearing appropriate personal protective equipment, such as safety glasses and gloves, de-energizing circuits before working on them, and using insulated tools. It is also important to be aware of the potential hazards of electricity, such as electric shock, arc flash, and electrical fires. Electrical drawings and diagrams are used to represent electrical systems in a clear and concise manner. These drawings typically include symbols for various electrical components, such as switches, outlets, and lighting fixtures, as well as wiring diagrams that show how the components are connected. Understanding how to read and interpret electrical drawings is an essential skill for electricians and other electrical professionals. Electrical testing instruments are used to measure various electrical parameters, such as voltage, current, resistance, and continuity. These instruments are essential for troubleshooting electrical problems and verifying the safety of electrical systems. Some common electrical testing instruments include multimeters, clamp-on ammeters, and circuit tracers. Electrical codes and standards are constantly evolving to keep pace with new technologies and safety concerns. It is important for electrical professionals to stay up to date on the latest codes and standards to ensure that their work is safe and compliant. This can be accomplished by attending training courses, reading industry publications, and participating in professional organizations. Electrical safety training is essential for anyone who works with electricity. This training should cover topics such as electrical hazards, safe work practices, and the proper use of personal protective equipment. It is also important to receive training on specific electrical tasks such as wiring circuits, troubleshooting electrical problems, and performing electrical inspections. Understanding electrical theory is crucial for anyone working with electrical systems. This includes understanding concepts such as voltage, current, resistance, power, and energy. It also includes understanding how these concepts relate to each other and how they can be used to analyze and troubleshoot electrical circuits. Electricians, electrical engineers, and other electrical professionals are responsible for designing, installing, and maintaining electrical systems. They must have a thorough understanding of electrical theory, codes, and standards, as well as practical skills in wiring, troubleshooting, and testing. They also need to be able to communicate effectively with clients, contractors, and other professionals. Renewable energy sources, such as solar and wind, are becoming increasingly important in the energy mix. Electrical professionals need to have a good understanding of these technologies and how they are integrated into the electrical grid. This includes understanding the design, installation, and maintenance of solar panels, wind turbines, and other renewable energy systems. Smart grids are advanced electrical grids that use digital technologies to improve the efficiency, reliability, and security of the electrical system. Electrical professionals need to have a good understanding of these technologies and how they are being implemented. This includes understanding concepts such as smart meters, advanced metering infrastructure, and demand response. Electrical troubleshooting is the process of identifying and resolving electrical problems. This requires a systematic approach and a good understanding of electrical theory and circuits. Some common electrical troubleshooting techniques include visual inspection, voltage testing, continuity testing, and resistance testing. Electrical inspections are conducted to ensure that electrical systems are safe and compliant with codes and standards. Electrical inspectors typically review electrical plans, inspect electrical installations, and conduct electrical tests. They may also issue permits and certifications. Electrical estimating is the process of calculating the cost of electrical work. This requires a good understanding of electrical materials, labor costs, and overhead expenses. Electrical estimators typically use software tools to prepare estimates and track project costs. Electrical project management is the process of planning, organizing, and controlling electrical projects. This requires a good understanding of project management principles, as well as technical knowledge of electrical systems. Electrical project managers are responsible for ensuring that projects are completed on time, within budget, and to the required quality standards. Electrical safety is paramount when working with electrical systems. Always energize circuits before working on them, use insulated tools, and where appropriate personal protective equipment. Be aware of the potential hazards of electricity and follow safe work practices. When working with electricity, it is essential to have a strong understanding of electrical theory, codes, and standards. This knowledge will help you to design, install, and maintain electrical systems safely and effectively. In electrical engineering, power systems analysis involves studying the behavior of electrical power systems under various operating conditions. This includes analyzing power flow, stability, and fault conditions to ensure the reliable and efficient operation of the grid. Electrical machines, such as motors and generators, are essential components of many industrial and commercial applications. Understanding the principles of operation, control, and maintenance of these machines is crucial for electrical engineers. Control systems are used to regulate the behavior of electrical systems and equipment. These systems can range from simple on/off controllers to complex feedback control loops. Understanding control system theory and design is essential for many electrical engineering applications. Signal processing is the analysis, interpretation, and manipulation of electrical signals. This includes techniques such as filtering, amplification, and modulation. Signal processing is used in a wide range of applications, including communications, audio processing, and image processing. Electromagnetic compatibility, or EMC, is the ability of electrical equipment to function properly in its intended electromagnetic environment without causing interference to other equipment. EMC is an important consideration in the design and installation of electrical systems. Power electronics is the application of solid-state electronics to the control and conversion of electrical power. This includes devices such as rectifiers, inverters, and converters. Power electronics is used in a wide range of applications, including motor drives, power supplies, and renewable energy systems. High-voltage engineering deals with the design, testing, and operation of high-voltage electrical equipment. This includes equipment such as transformers, circuit breakers, and transmission lines. High-voltage engineering requires specialized knowledge and expertise. Electric power transmission involves the bulk transfer of electrical power from generating stations to distribution substations. Transmission systems typically operate at high voltages to minimize losses and maximize efficiency. Electric power distribution involves the delivery of electrical power from distribution substations to end users. Distribution systems typically operate at lower voltages than transmission systems. The smart grid is a modern electrical grid that uses digital technologies to improve efficiency, reliability, and security. Smart grid technologies include smart meters, advanced metering infrastructure, and demand response systems. Renewable energy sources, such as solar and wind, are becoming increasingly important in the energy mix. Integrating these sources into the electrical grid presents both challenges and opportunities. Energy storage technologies, such as batteries and pumped hydro, are becoming increasingly important for balancing the supply and demand of electricity. These technologies can help to improve the reliability and efficiency of the electrical grid. Electrical safety is paramount when working with electrical systems. Always follow safe work practices and use appropriate personal protective equipment. Grounding and bonding are essential safety measures that help to protect people from electric shock and prevent damage to equipment. The National Electrical Code, or NEC, is a comprehensive set of standards for the safe installation of electrical wiring and equipment. Always adhere to the NEC when working with electrical systems. Electrical testing and measurement are essential for troubleshooting electrical problems and verifying the safety of electrical systems. Use appropriate testing instruments and follow proper testing procedures. Electrical drawings and diagrams are used to represent electrical systems in a clear and concise manner. Understanding how to read and interpret these drawings is essential for electrical professionals. Electrical codes and standards are constantly evolving to keep pace with new technologies and safety concerns. Stay up to date on the latest codes and standards to ensure that your work is safe and compliant.